Section 1.8, higher order derivatives. So we recall that when we have a function y prime, or some people write it as f prime, or another way to write it dy dx, that's called first derivative. That's called first derivative. Now, if I find the derivative of the derivative, that's called the second derivative. Or you can write it this way: the derivative of the first derivative d dy dx with respect to x. Watch how I wrote it. D of this parenthesized amount dx, or it can be written as dy squared dx squared. This is just notation for second derivative. Now it's easy to see the next one. Third derivative would be 3 dashes like this, 3 prime, triple prime, or you can write it d cube y dx cube. Third derivative. Y to the fourth. From fourth on, we start writing 4 instead of keeping writing those dashes. Y to the fourth, which is the fourth derivative with respect to x. That's called the fourth derivative. And this keeps going on and on. Those are called higher derivatives. So we're going to find the fourth derivative of this function, y equals x to the 7th minus 8x squared plus 11. To do that, we need to find the first derivative. Very easy, by the power rule. 7x to the 6, 16x plus 0. That's the first derivative. The second derivative, 42x to the 5th minus 16. That's the second derivative. The third derivative, multiply 42 times 5 is 210. X subtract 1 minus 0. One more, the fourth derivative that I'm looking for, that's d4y dx to the 4th. 4 times this is 840x cubed. Find only the second derivative for the function y equals x squared plus 5x all to the 6th power. How do you find the second derivative? Y prime. First, to do this, we need to use the chain rule. So y prime equal, by the chain rule, 6x squared plus 5x to the 5th power times the derivative of the inside, derivative of this, which is 2x plus 5. I'm going to slow down for that. That's only y prime. Y double prime, keep the 6 out, it's not going to make a difference. Derivative of this one, bring the 5 down, x squared plus 5x to the 4th power times the derivative of the inside, 2x plus 5, times the other one. So I just brought that one down, plus keep the first one the same by the product rule, times the derivative of this, which is 2. And if you want to leave it like this, it's fine. That's the second derivative. So before we find the first derivative, let's keep this the same for now and rewrite this as x to the 1/2. Then y prime, bring the 4/3 down, x subtract 1 from the exponent, minus bring the 1/2 down, subtract 1 from the exponent. So y prime is 4x to the 1/3 minus 1/2 x to the negative 1/2. That's only y prime. Then y double prime, bring the 1/3 down, subtract 1, bring the negative 1/2 down, subtract 1. So y double prime is 4/3 x to the negative 2/3 plus 1/4 x negative 3/2. And since this is the final answer calculus wise, we must bring the negative exponents down. So that makes it positive 2/3. That makes it positive 3/2. Anyone has any questions about this? To do some application to this, we let s of t, we call it the position function, position of an object after time t from its original position. That's s of t. Also, we have v of t. That's the velocity of an object that is s of t units from the starting point at time t. That's what v of t is. Now, what's the relation between v and s of t? V of t is the derivative of s of t. So if I rewrite it as prime of t equals v of t, if I differentiate both sides again, I get double prime of t, like the second derivative, equals v prime of t. This v prime of t is called the acceleration, a of t. I'm gonna write an example down. So we have an example here given s of t. The position function is given as 4.9 t squared. A stone is dropped from a cliff. How far the stone has traveled 4 seconds after being dropped. How far means the distance, the position. So to do that, we need to find s of 4 after t equals 4 seconds. All you have to do is just substitute 4 for the given function for t. And 4 squared is 16. Then you multiply 16 times 4.9. You get 78.4 meters. This is just application for higher order derivatives. Part B, how fast? How fast it is traveling 4 seconds after being dropped. V of t, because velocity, how fast means velocity. We define v of t to be the derivative of s of t. And we are asked to find v of 4. I will add another part to it. Find the acceleration after 4 seconds. So let's look at this one, s prime of t. So what's the derivative for s of t was 4.9 t squared derivative. So if you bring 2 down, multiply by this times the t, subtract 1. So you get 9.8 t. Then we need v of 4, 9.8 times 4, which is 39.2 meters per second. So now we need to find the acceleration. What is acceleration? Acceleration a of t is the derivative of v. Derivative of v. What is v? This is v of t. So it's the derivative of 9.8 t. Derivative of this is simply 9.8. And usually the units, it's meter per second square. Any questions about this?